So now when you create your element sets, and we want to create this element sets here, so we want to extract these node numbers here, 1, 2, and 3 for any element size. So you want to create a set that is dynamic, that changes with the with your mesh. These guys here, and also this coordinate here, the very far end, the top. This is where we're gonna apply the load, and this is where we want to apply the boundary conditions. So we want to set the displacements to be 0 in the x and y directions in all of these nodes here. I want to extract the node numbers here. And how am I going to do this? Well, we use the function find in MATLAB. Alright, so what I mean is these coordinates here are at x0. So what I can do is this. I have p, and then take all of the rows and then 1. So these are my x coordinates. I want to find out the numbers of these guys here, the node numbers, the position numbers. So this is the node numbers for p is now 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I want this to return 1, 2, and 3 because at those positions p is equal to 0. So the first thing I'm going to do is do double equal sign and then 0 here. So what MATLAB is going to do now is it's going to return a logical array with ones wherever this statement is true and 0 wherever it is not true. So it is true at these positions here. So now I want this logical array to be converted into 1, 2, and 3 because, well, this is the position. So in order to find this position, we just use the command find. So we throw this in here into find like this, and it's going to return 1, 2, and 3. That's that simple. Now if we had a 1 here, it would return that number. So it would return 1, 2, 3, 4, 5, 6, 7, 8 if this was a 1. And we can actually try this. If we use a logical, we can just use logical like this, and then this array here like this, and we can use find on that, and it should return the number 4. Alright, so hopefully you understand how find works now. So you can use find, so you can just copy this command and we can throw it in here and say that the boundary conditions, let's call it BC1, is this. Okay, and let's evaluate that again. And we see that BC1 is this. Cool. Alright, so BC2 now. Well, for BC2 we want to find when this is at the furthest away, which is at h is equal to 10 here. Well, at h, or actually, sorry, at L. L is equal to 10. This is the length. Alright, so we do find P1 is equal to, we can use L directly, so we get this. Alright, but it's not just that, it's also at the top here, which should be 10, which should be H. Okay, so if I just copy this from here, from find, remove find, I can see I have this. And now what I can do with this is I can add and to this, and I can copy in the second dimension here and say that I want this at H as well. Okay, so this will return 1. Now what does this do? Well, okay, let's do it like this. Let's create a vector or a matrix. So we throw this in here like that, and then we also take the other one and we put it just next to it. Okay, so this is a row vector, and then we can put another row vector right next to it because they're the same length. So what I'm telling MATLAB is now give me back the result where the ones are where all the ones are at the same place. This is what the AND sign does here. Okay, it's basically like saying, taking this here and putting all in front, the function all, and then saying that we want to do this in the second dimension here, across column wise. So it checks like all the columns, or all of the columns 1, and returns 1 if they are. So instead of writing this, we can write and here. Alright, so this is one conditional statement, and this is another conditional statement. And if both of them are true, then it will return 1. And since these conditional statements are now vectors, then it will output a vector. Okay, so now what we do is just wrap this in find, and we get the node number 9. Yeah, let's copy this in here and say that the BC2 is equal to, and then this. Actually, let me get rid of this and I can just run this, and we see here that BC1 is 1, 2, 3, 1, 2, 3. Yeah, that's good. And BC2 is 9, and that is also good. So what about if we increase the element numbers here? So let's verify this. We have 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6. That's good. And then 36. Hey, that's great. So now we have extracted the nodal sets that we are going to need later when we apply the both the load and when we apply the boundary conditions.